Yeah, I probably wanted to mute myself in the beginning. But so there's 4 sign changes from positive to negative, negative to positive, positive to negative, negative to positive. So what that tells us is there's 4 possible positive roots. There can be less than 4, but they have to come in pairs. So I could have 4 possible positive roots, or I could have 2 positive, or I could have 0 positive. They have to come in pairs. So if I'm creating a little data table, positive, negative, and then imaginary roots, which we'll talk quite a bit about later, I could have 4 positive, I could have 2 positive, or I could have 0 positive. That's the easy one. The hard one's the negative. And what it tells me to do is replace f of x with f of negative x. So f of negative x says plug in negative x for x. And what that does is anytime it's an odd exponent, it changes its sign. So if I plug negative x in here, this becomes negative 3x to the 5th. That's an even exponent, so it doesn't change. That's an odd exponent, it changes. Even exponent, odd exponent, no exponent. So all the ones with an odd exponent change signs. Now I count my sign changes. Negative to negative, negative to negative, negative to positive. So there's 1 sign change. Positive to positive, positive to positive. So there's only 1 positive sign change. What that tells us is there's 1 or 0 negative roots. So there's either 1 or 0 negative roots. How many roots is this going to have total? From what we talked about on Wednesday, how many roots is this going to have? How many zeros? 5. Yeah, up to 5. Remember, it's your highest degree. So we could have 4 positive and 1 negative. We could have 2 positive, 1 negative, and that would mean there are at least 2 imaginary. We could have 0 positive, 1 negative, 4 imaginary. 4 positive, 0 negative, and 1 imaginary. Really can't happen. You actually have to have them in pairs. So although for the table purposes, we could write this down later, we'll find that that's not possible. Neither is 2, 0, 3. That's not possible. They have to be in pairs. And 0, 0, and 5. That's not going to be possible later. So when we really look at it in the long term, it's going to be one of these. We'll either have 4 positive, 1 negative, no imaginary, 2 positive, 1 negative, 2 imaginary, 0 positive, 1 negative, 4 imaginary. We'll get to that. That's coming in this lesson. Like not today, but next week. We'll start talking about complex numbers. And I mean, you talked a little bit about imaginary in IM3, but we're going to go further into complex numbers and their conjugates. All right, so that's what Descartes' rule of sign is. The rational zero theorem The rational zero theorem says that all zeros, if it's a zero of a polynomial, it has to be a combination of P over Q, where P is the factors of the constant and Q is the factors of the leading coefficient. I'll let you write a second, then I'll explain it. So if I look at P over Q, P is all the factors of the constant. Well, the constant, remember, is the one that doesn't have anything with it. So if I look at my factors of 4, they would be plus or minus 1, plus or minus 2, or plus or minus 4. Those are all the factors of 4. Q is all the factors of the leading coefficient, the first one, 6. So the factors would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are the only numbers that can go into 6. Those are all of its factors. So when we start talking about all possible roots, all possible zeros, we have to take all combinations of these, P's over Q's. So I can do 1 over 1. So plus or minus 1 over 1. I'm just going to use this 1 up here. Plus or minus 1 over 2. Plus or minus 1 over 3. Plus or minus 1 over 6. Then I'll move on to the 2. Plus or minus 2 over 1. 2 over 2 is 1. I already have that. Plus or minus 2 over 3. 2 over 6 is 1/3. I already have that. And then I go on to 4. Plus or minus 4 over 1. 4 over 2 is 2. I've got that. Plus or minus 4 over 3. 4 over 6 is 2/3. I already have that. So these are all of the possible roots. These are the only possible real roots. 5 is not a root. I know it's not on the list. 6 is not a root, not on the list. It has to be on the list to be a possible root. If it's not on the list, it's definitely not a root. Okay. We're going to talk about 2 more things, and then we'll bring this all together. So there's the rational zero theorem. Descartes will assign long division. Synthetic division is nice, but synthetic division doesn't allow us to work if we have a leading coefficient. The leading coefficient has to be 1. So long division sometimes comes into play. And you set it up just like you did when you were a kid. 4x cubed minus 6x squared plus 4x minus 7 divided by 2x minus 1. So you're going to set it up the same way that you did when you were learning long division in 3rd grade or 2nd grade, whenever you learned it, or 1st. I don't think I did in first. I think Miss Lisa told me in second. Okay, so now when I'm doing long division, I'm really only caring about this one here. I really only care about that leading one. This -1 comes along for the ride, but what do I have to multiply 2x by to get 4x cubed? I gotta multiply it by 2 and x squared. Now, I'm going to take that 2x squared and I'm going to multiply it here. I get 4x cubed minus 2x squared, because 2x squared times -1. And then I subtract. Minus a minus is a plus. Those go away, and this ends up being -4x squared. And I bring down the next term. What do I need to multiply 2x to get -4x squared? Not +2, but -2 and x. So -4x squared minus a minus is a plus. And I subtract. 4x's minus 2x's is 2x's. And I bring down the last thing. What do I have to multiply 2x by to get 2x? 1. -7 minus the -1 is -6. Now, what did we call this in the old days? A remainder. It still is. We just write it a little bit different. We would write this as -6, so I'm going to put it as -6 over what I divided by, 2x minus 1. Because that's what a remainder was. If I tried to divide, say, 50 by 7, how many times does 7 go into 50? 7, because that's 49. I have 1 left, and this is the same thing as 7 and 1/7, because it goes in 7 and 1/7 times. So that's what we do. The shortcut to this whole thing is synthetic division. And synthetic division works if we just have an x. So we don't have a leading coefficient. And the way we're going to set this up, there's one thing you have to be very careful of right here. There's one thing to be very careful of. Watch this. Hey, I'm going to put this on the test. You're going to want to see this. Guaranteed this is on the test. You're going to miss it if you don't watch this right now. Watch this right now. Hey, guys, don't forget about this. Watch this right now. Okay, do we understand that now? This is on the test, and this gets missed all the time. I'm going to write down the coefficients. 4x is x to the 4th. Now, I don't have an x cubed term. I have to put a 0 in for the x cubed term, the missing one. If you don't put the 0 in, you get it wrong. It won't work. So if you're missing a term, and then I can put the -2, the 1, and the -7. If you are missing a term and you don't put a 0, it won't work. And in here goes the 0 of the denominator. or what you're dividing by. So what's the 0 of our denominator? -1. Because if you remember, our factors are x minus a. So when I'm talking about factors, it's the opposite sign. It's what the 0 is. Now, bring the first one down. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. So when I divide this, I've taken out one factor. So my x value goes down by 1. So instead of this being x to the 4th, this is now 4x cubed minus x squared plus x minus 1, and then your remainder. So it goes down by one factor because I took out 1x, took out a factor. The other part of this, which is very, very useful, is that if you plug in -1, so if I go to this equation and I plug in -1, I'm going to get the remainder. I'm going to get -6. So if I plug in -1, I get 4 times -1 to the 4th minus 2 times -1 squared plus -1 minus 7. 4 minus 2 minus 1 minus 7. That's 2, 1, -6. So synthetic division also allows me to plug numbers in super fast. Like if I wanted to plug 7 into this equation, I could take the 4, 0, -2, 1, -7. If I want to plug in 7, bring down the 4, 28, add. For 196, this is going to be an awful number because I just chose it off the top of my head. 21, 2, 63, 65, carry the 6, 1351, so it's 1352, 14, carry the 1, 35, 36, carry the 3, 21, 24, carry the 2, 9, 4, add, 9, 4, 5, 7. It is. If I plug 7 in here, I'd get 9,457. Now, if I asked you to do it without a calculator, even I would have a hard time to that, because do you know what 7 to the 4th power is? 49. Yeah, 49 times 49. Do you know that one? Do 50 times 50. Noble attempt, but no. 49 times 50 and minus 2. You could do 49 times 50 and then subtract 49. Yeah. But still suck. So I couldn't do it off the top of my head, but I can do this off the top of my head. So synthetic division's 49 times 49, it would end in a 1. Seems reasonable, because 50 times 50 would be 2,500. Seems reasonable. Yeah. All right. So try that one. Use synthetic division. Try that one real quick. Should take you about 18 seconds. Yeah, he's right. But the amount of time it took us to find 7 to the 4th power is greater than the time it took me to do that whole thing. Synthetic division's my friend. Synthetic? You better relearn it, because you're going to need it in AP Calc.
No, I don't need to. I just forgot it.
I know. You're going to need polynomial long division in AP Calc too.
That's easy stuff.
I'm glad you think so.
This is hard stuff right now.
Good. I hope you know that I'm recording
good,
this
right?
lesson right now. Yes. Say hi to our distance friends. Is that what you got? Okay, so since the remainder is 0, we can definitively say that -3 is a factor of that polynomial up top because it gave us a remainder of 0. It divided in evenly, therefore it's a factor. If I wanted to find the rest of the factors, I could then take this equation here and either factor it or use the quadratic formula or whatever, because I'm down to a squared. But what if, Mr. Johnson, that seems way too easy. What if I get something like this? And it says, find all of the roots of x to the 5th plus x to the 4th minus 13x cubed minus x squared plus 12x. How many roots are we going to look for? 5. So we're going to have 5 roots. If I do my p's over q's, p is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are the factors of 12. And fortunately, the q's are only plus or minus 1. So my possible zeros end up being just my different p-values. So those are the only possible factors. I will add in that 0 is always a possibility. Like in this one. Well, let's do a couple things. Let's use Descartes' rule of signs. How many sign changes do I have? So that's positive to positive. Positive to negative, that's 1. Negative to negative, negative to positive. So how many positive signs can I have? Okay, close. I can have 2 or 0. So I could have 2 or 0 positive. If I plug in negative x and I change the sign of all the odd indexed, then I have 1, 2, right? Let's see. 1, 2. Yep. So I can have 2 or 0 negative. But looking at it right away, what can I do to start factoring this? What can I do to start factoring this polynomial? How do we start factoring every polynomial? Yeah, they all have a common value of x. Oh, might help if I actually took one out. Golly. So I factored out this x, so I know that one of my zeros or one of my roots is 0. Cool. I only have 4 more to find. And here's where synthetic division can make this pretty quick. I no longer have to deal with this whole thing because I factored an x out. So I'm just going to deal with this part here. And I'm going to write down my coefficients. 1, 1, negative 13, negative 1, 12. And as a mathematician, this is the point where I really like to switch to pencil because I don't like to write things down a whole bunch of times. So I'm just going to try different values like 1. All right, so 1, 1, 2, 2, negative 11, negative 11, negative 12, negative 12, and 0. Got lucky. So I know that 1 is one of my zeros because it worked. So I'll go ahead just so you can see it and write it over like that. Now, you don't have to start back up here anymore. I can start here. And I can actually just do one of these things because I took a factor out. And I could try another number. Like, I don't know, what do you want to try? 2? So 1, 2, 4, 8, negative 3, negative 6. Did that work? No. So I know that positive 2 is not one of them. So I can erase that. Try 3. 1, 3, 5, 15. Right? 1, 5, 15, negative 4, negative 12. Nope, that didn't work either. Do what? Oh, did I? My fault. 1, 3, 5. Where's the normal? 15. Oh, this is 4. This is 12. It does work. Yay, math failed me. Hey, I make mistakes all the time. It's hard to talk and write at the same time. So I know that 3 is one of the factors. Now, are there any more positive factors? Could there be? Could there be any more positive factors? No, Descartes' rule of sign said there's either 2 or 0. How many do I have? 2. If I wanted to continue on this path, don't look at positives anymore. None of them are going to work. So you'd look at negatives. The other thing you could do is when you're down to this final 3, you could write it out as x squared plus 5x plus 4. And then this is factorable into x plus 4, x minus 1, or x plus 1. And so my other two factors are -4 and -1. There are all of my roots. Oops. There are all of my roots of the equation. The only other thing that sometimes they want you to do, because they're mean, is they want you to write it in factored form. So they're going to want you to write it as f of x equals x times x minus 1, x minus 3, x plus 4, and x plus 1. So it's in factored form.